Saucier, this is a video lesson on fractions, specifically reducing them. For example, we could have the fraction 4 over 2, or 4 divided by 2. Reducing a fraction is a way of simplifying it. If we divide 4 by 2, we do get a simpler way of writing the same value down. 4 divided by 2 is equal to 2. In this case, we simplified and we reduced. But very often it doesn't work out quite as nice as that. For example, we could start with the fraction 8 over 16, or 8 divided by 16. We may be able to reduce this. In this case, if we found a number that divides both 8 and 16, then we know that the fraction can be reduced, and we can find a simpler way of writing the fraction. In general, if you can find a number that divides the numerator and denominator, the numerator is the top number, the denominator is the bottom number, then the fraction can be reduced. Let's see this happen with the fraction 8 over 16. 8 divides the numerator 8, and 8 divides the denominator of 16. We know because we can write 8 as 8 times 1. And we can write 16 as 8 times 2. 8 is the number that divides both the numerator and denominator in this case. And we can reduce it by thinking of this fraction, the way that it's written here, as 8 over 8 times 1 over 2. We've separated out the part that is 8 over 8 from the part that remains 1 over 2. Something over itself can be written as 1. So in this case, this is the same thing as 1 times 1/2. And anytime we multiply by 1, we can ignore it because multiplying by 1 doesn't change the value of the thing we're multiplying. In other words, I can ignore this multiplying by 1 and simply get the answer in the end of 1/2. Now this process can be sped up. For example, if I start with the fraction 35 over 75 and I want to reduce it, I'm looking for a number that divides both the numerator 35 and the denominator 75. With a little bit of investigation, and a calculator can help, I can discover that 5 divides 35. I can think of 35 as 5 times 7. 5 also divides 75, and I can think of 75 as 5 times 15. This number that divides the numerator and denominator we can call a common factor, and it cancels out. It turns into 1. The 5 divided by 5 turns into 1 and can be ignored, leaving the 7 over 15. Which is the reduced fraction. See another example. the fraction 13 over 17. If I'm going to reduce this, I'm going to look for a number that divides 13 and divides 17 evenly. Searching for a number, I won't be able to find one. I can't find a number that divides 13. I could try 2, doesn't work. 3 doesn't work. I will not find a number that divides 13 or 17, let alone the same number. The reason for this is because 13 and 17 are what we call prime numbers. So this fraction can't be reduced. There is no number that divides both the 13 and the 17. So we can't write it in simpler terms. We'll simply stop there. Let's see another example. 24 over 36. I'm looking for numbers that divide both 24 and 36, and there are many of them. Doesn't matter which one I choose. I could start with one that I think of immediately, like 4. 4 divides 24. If we divide 24 by 4, we get 6. I can show that as 4 times 6. 4 also divides 36. 36 divided by 4 is 9. I can show that as 4 times 9. And we cancel out the common factors of 4, leaving 6 over 9. But I'm not finished. I might be able to find another number that divides the new numerator and denominator. 6 over 9 can be reduced further. A number that divides 6 and 9 is 3. I can express 6 over 9 as 3 times 2 over 3 times 3. And now cancel out that new number, which then leaves 2 over 3, which cannot be further reduced. So we'll stop there. One more example. 6 divided by 35. I'm looking for a number that divides 6 and 35. I know that 2 and 3 divide 6. I can show 6 as 2 times 3. I know that 7 and 5 divide 35. I can show 35 as 5 times 7. But in finding numbers that divide the numerator and denominator, I found some, but they are not the same. There is no common factor to cancel out. So I did not find a number that divides both the numerator and denominator. It can't be reduced, so I'm going to show it as 6 over 35 as the final answer.